Hi everyone, welcome back to my YouTube channel. So, where do I begin with this one? So, a year ago, or 1 year ago, I built this project. I call it a linear welder, basically because I attach my TIG torch to it and apply welds on workpieces, such as the one in the background, and other workpieces, but it was built with the intentions of enhancing this manifold and making the welds nice and neat for decorative welds or imitation. They imitate nice beads after each other. So first things first, I will bring the manifold up closer to show what I'm talking about. Okay, so this manifold was built a long time ago now, 2 years ago. It was started 2 years ago. So the manifold is built and there's two plenums on it. A plenum at the front and back bank are 300mm long from here to here, each one of them. So the manifold was built from a Honda V6 engine, and I wanted to make it as attractive as possible. So in doing that, I designed this thing in the background here for welding it nice and neat. So basically, what I mentioned there is I attached my TIG torch to it. Let me see. I attached my TIG torch to it at this point and turn this wee unit on and turn the welder on at the same time. So what I'm going to do now is I'm going to bring the camera up close and do a wee walk around of this project before we go on to the actual video clips of when it was being operated. I think about 14 months ago, maybe longer actually. It's a long time ago now. So I'm going to bring the camera up close. Then we're going to do, after the demonstration, we're going to move on to the video clips. But please bear in mind, in the video clips, I've recorded the actual unit in operation with my phone. And I am saying all the time, what am I mentioning again? What did I say? I say a little project that I have completed that day, which that day is actually 14 months ago, or maybe longer now. So I'm going to bring the camera up close now and we're going to do a walk around on the actual project itself. So I'm going to try not to miss anything. So it's getting dark now too, the sun's setting. So this is the manifold. I'm not going to talk about this in detail at all. So as you can see here now, I polished this in the mirror right around everywhere, and you can see it actually quite well there in the dark now. So from here to here was welded, TIG welded, stainless obviously. So I then sanded it and hand polished it, or then used machine polish to bring it up to this nice mirror finish. But in doing that, I always wanted to apply a weld from here to here. But to see the way there's still polish left on this manifold here, that needs to be removed before I apply the last bead. The last bead, the weld, will be applied using this machine. In the video clips, you see me sampling with it on the plenums individually. That machine hasn't been using this manifold since. I'm actually in two minds whether to touch the manifold now because it's in such a good condition. If I bring this near it and I make a mistake, I can't exactly strip the manifold again. If I leave a scratch in here, or etc. So I'm going to now move on to this. This is what the video is about. So I'll need to be quick because it's getting dark. Okay, so what we have here is a TIG torch. The TIG torch attaches to this stainless bar, which is 8mm bar. Stainless bar, it's all stainless. What we have here is adjustment for the torch. So I can adjust the torch up and down from the workpiece itself, or this manifold, the plenums. So basically, you attach this to the bench, you clamp this to the bench, tack it to the bench, whatever, and then you clamp the manifold plenum to the bench. Obviously, I'll remove this Y piece that I built when I go to weld it again, if I do, because as I say, I don't really want to touch it again. A wee bit worried, a wee bit scared. So see here the way they got the burnish effect, the heat, that's what I want to leave on this mirror effect. But to do that, I need to remove these polish give it a final polish, and then I have to weld it again along this bead, just to leave a nice bead from here to here. Trying to do this with your hand is, no, it's not easy, because no, you'll never get it exact. So you will see in the videos that I leave a nice bead from here to here, and you can see the burnished mark. The heat mark is, well, it's parallel with its edge. It doesn't distort or anything like that. It's well, is it well balanced? Is that the word I'm looking for? No, not balanced. It's parallel to this edge. A nice tarnish effect. So that's basically what I'm using it for imitation or really nice weld. So we're going to move into this now. So what we have here, right, is a cross member channel. That is the main frame. We have two guides out of 25mm stainless angle iron. We have a 12-volt motor. We have two screws. The screws is welded together in the middle here. So if you look closely here, if I bring the camera up, you can see that the screw is continued on the other one. So basically what I've done here is I've welded them, and I've shaped this back into the screw effect in order for the brass blocks in here to pass over the weld. This is crucial at this point. So if these brass blocks were slowed or tended to slow down at this point, the weld bead will get very tight and unbalanced when it's welding, which I don't want. So this was a lot of work. So another thing I should mention here, when this here is turned on, at this point the motor has more torque. There's more spring in the shaft at this point, if it makes sense. It's really hard to describe here. So basically what I'm saying here is these two angle irons needed to be a wee bit slacker at this end and a wee bit tighter at this end to balance things up. So I'm going to take this off here, and so what I've done here is I've made a wee bracket up to hold the TIG torch on the TIG welder. So basically that TIG torch sitting there. I'm going to move on what actually these screws and this motor's out of in a wee minute. So below this we have two brass blocks. Let me get this off fast enough here. One more, just 2 seconds. So below this we have two brass blocks. As I say, I clamp the TIG torch to that bar, and the TIG torch moves up and down on that axis, parallel to the bench or to the workpiece, which is that manifold. So here we have two brass blocks. The reason I have two brass blocks here, not just one, is because it's more sturdy this way. The further you have these placed apart, the more sturdier this base for holding the TIG torch is. These brass blocks have a very minute, really small bit of play between the guides and the brass block themselves. There's obviously a wee bit of grease, helicopter grease on this shaft, or this linear screw. Moving on. So over at this end we have basically a bridge type bearing housing that holds the bearing. This bearing is 20mm outside, 6mm diameter inside, and we have two 5mm screws holding the bearing, pushing the bearing up to the top. This is a dairy pipe bend cut out in a bridge effect to hold the bearing, to enclose it, to support it, and this is just tacked to the base. These screws, this is a lock nut to hold the screws and them vibrating out or whatever. Obviously this doesn't go very fast, it moves very slow and millimeters per second, like very, very small. I don't know what it is, I'm not going to lie. So it can be anything, it can be 1mm a second right up to, I don't know, 20mm a second. You know, you can speed it up using this buck boost converter. In the video clips you will see that I have just a power supply at the beginning when I've experimented with this with a 5-volt power supply. Obviously that's going to half the power going down. This is a 12-volt motor. Anything up to 12 volts or a wee bit more for speed. So there's the brass block that's on another. Okay, so I should mention, right, this unit here that you see here is exactly what's in this linear welder or axis controller, whatever you want to call it. Basically I have welded them together, as I've mentioned, and they are out of a car seat, actually a Honda Legend car. So anything Japanese is really robust and strong, and they caught, especially back in the late or early 90s, even late 80s, the brass blocks and stuff that come in cars back then would be more of a higher quality, obviously. Things was far better back then. Probably in a car now, it's probably a piece of nylon or something. Okay, so what I have done here, right, is I have cut this shaft. So this is out of the passenger side of the car, and this one's out of the driver's side, which I have now have on this. Basically, there's a motor here with a gearbox and another gearbox that controls each side of the car seat. I'm only using the motor, I'm not using the gearbox for the other side. So what I have done is I have cut this off completely, and cut it off completely here, and cut it off completely here. And I have brought the two screws together. But you have to keep in mind here, the two screws need to be going the same direction. You can't just cut this one off and cut this one off and bring them on this way, because the two of them are going on opposite direction. So when the brass box tries to pass over, just stop, dead stop. So what I have done, I had to weld this end onto here when it was cut clean, and I had to match the screws up, the threads, if you want to call them. So that's it. That's out of a Honda Legend. Really good equipment back then. Look at the quality of that brass block and the fitment and the screw there. Like. Okay, so that's it. I think I've discussed everything. All right. Okay, I should mention the brass blocks. In order to hold the TIG torch bracket. So you can see this bracket's adjustable too for the workpieces I've mentioned. So in order to hold this bracket for the TIG torch, I had to tap the brass blocks out to bore them to 4.2mm, and then tap them to 5mm thread, M5, to hold that bracket. That's it. So please bear in mind in the videos when I am talking about this, there's lots of video clips put together on the demonstrating purposes. They were done 14-15 months ago. So they're very, I don't know, they were recorded with my phone. Not professional. So as I say, this is a buck boost converter or a voltage regulator, variable voltage regulator. It is used to control this motor for speed. When I am welding this plenum at the end of this video, the clips, you will see that I am using the voltage regulator, and I think there's 3 volts or something set onto this. So what I want to do is I want to have a nice balanced these blocks to get from A to B here, and a nice balanced speed. So to do this, the pressure needs to be the same against the blocks. It's really hard to describe. So at the motor end, it needs to be a wee bit, because the motor's up near the motor, maximum power up here, maximum force you could say. Down here you tend to get a bit of, imagine that there, bar being a mile long, there'd be very little power in the end of it, the bar would spring. So what I have done here is I have slackened the guides a couple of thou out this way, and a couple of thou in the way here to try and compensate that. So that's it. We're now going to move on to the video clips. I hope I haven't missed anything. I don't think I have. So I hope you enjoyed. I hope you enjoy the clips even. That's it. A little machine I made today. It's like an automated process for welding 2 pieces of metal together. I'm going to weld these continuously, and I won't be holding the TIG torch. This actuator, linear actuator and screw is took out of a car seat, and there's actually 2 welded together. There's 2 brass blocks here, slides down on the screw when it rotates, and there is a 5-volt power supply driving it. So here we go. Going to start the welder now. Going to use one hand. Okay, we'll start the welder first. So this out. So it's welding now, continuously. The wee screws turning, like so. This is welding away. I should point out the manifold plenums are coming after these test pieces. A little machine I made today. I'm going to weld these 2 pieces of metal together. and I won't be holding the TIG torch at all. I started this morning. This linear bar is welded together in the middle. It used to be a part of an electric seat in a car. I'm using this wee 12 volt motor. Supplying it with 5 volts, and I'm going to start it and weld this using pulse. So here we go. I'm welding at 65 amps and I'm ready to plug this in. Right, I'm going to kick this with my foot after I press start the TIG. Okay. Okay, so we're away now. Going too fast though. A little project I bought today. TIG welder connected up to this automated welding machine. So we're going to weld these two pieces of metal together. Okay. So various settings are used throughout the next video clips, the on cycle and off cycle, so you will hear a change difference in the welder, change in the tone. Automated welding using the TIG welder. I'm going to weld these two pieces of metal together. As you can see, I already done it, but it was going too fast, so I slowed it down now, and I'm going to do a sample here now. A little video to show this contraption working good now, using a voltage regulator that slows the motor down to a nice even pace. So I'm going to start here now to show you. So I will start rolling this motor first. I turn it on here. Okay. So we're welding now and we're pulsing. It'll look far better than yesterday, hopefully. Okay, so as you can see here in this video clip, the voltage regulator is used to slow the system down by a vast or large amount. You can also see that the device is more than capable now of welding the two pieces of stainless together. We're actually welding two pieces of metal together today, and I'm going to stop it now. So as you can see, nice. Okay, so this time the pulse settings in the welder are increased, so more pulses in a second. Just to experiment and see, just see the outcome of the weld itself and see what it looks like. You can see the shaft spinning here. At this point you can see the brass blocks passing over the weld, where the two linear screws were welded together. Lovely weld on the automated machine I made today. She's a beauty. I'm gonna turn it off. So we have an actuator at a car seat and two screw bars welded together in the middle, and a wee bearing on the end. As you can see, pretty nice. Nice weld. Okay, so during this test I'm doing a continuous weld just to see what the outcome. Also, you may notice there in the clips, the guide on the welding, or the linear side the linear screw, the guide is completely different. It is a bit of 2mm stainless steel instead. However, this wasn't sturdy enough, so that's why I moved to the other angle iron as well as a guide. Okay, so back to pulse again, just a wee experiment again, see what happens. So many tests need to be completed before I can put this near my manifold. Okay, so the pulse is increased here to make a nice even bead at the current settings amperage. So the wall thickness of this box iron is the same wall thickness of the manifold, 1.5 mil. So to get the best weld or the best outcome, as you can see there in the background, it's not too bad there now. Well, it's a bit gappy. So the pulse settings, the current settings, and the speed the screw is rotating at is vital, very important. So one compensates the other. So if you back one off, you need to increase the other. Okay, so the next clip shows the applying the weld to the plenum itself. Okay, so you can see there the weld's nice and neat and not as dirty as it was on the old box iron. It's crisp and clean and nice. The beads are nice, evenly placed. You can also see a nice burnished effect in either side of the weld. It's quite actually difficult to see this because of the mirror, but you can see the tarnished brown effect. Okay, so the final images of the plenums beside the actual linear welding system. So you can see here the plate used to hold the plenums down. This is a nice photo of it finished. There's a nice clean crisp weld, nice evenly patterned weld beads. This is the two welded and finished. However, I sanded them again and polished them in the mirror, as that was only a test piece. Well, the weld was only a test. The flash, I call it. So the manifold is now assembled back together, welded and all, but I am thinking about using this system to apply a nice bead on that edge in the future, whenever I get time again to start working at my project car. So this is a manifold finished. If you want to see this manifold, please go to my other videos, my YouTube channel. Thank you for watching, everybody. Please don't forget to subscribe and like. Coming soon, largest aperture in the world.